Here we have a small cube and a large cube, and there's a relationship between their sizes because they are similar three-dimensional figures. We call that relationship, which is a ratio, the k-value. So the k-value between this large and this small cube is 5/3. It means that any distance that we know in the small cube, if we want to find that same distance for the large one, we multiply it by 5/3. And then we can do this forwards or backwards. If we want to know the distance of something in the small cube, and we know it for the large cube, then we divide by 5/3. So we have to know that the k-value goes with distance. There's two ways that I can give the ratio. I can give the ratio like I did here. Here it is. You're just given two numbers that have a relationship. But I could also give you the side lengths of the two cubes, for instance, and then you could derive the ratio yourself. So for instance, if I said the side length of the big one is 10 and the small one is 6, well, that gives a fraction of 10/6. But you can reduce that fraction and you would get 5/3. So it's a different way of providing the student with the ratio. Then, if we're working on a problem where we have to deal with the areas of these two shapes, we cannot use this same ratio. 5/3 means the big one is 1.67 times as big as the small one. All I did was convert this fraction into a decimal to get that. But the area relationship is not the same. To get the ratio of the areas, we have to square the k-value. So k squared here is 5/3. That's 25/9. And 25 is not 1.67 times as big as 9. 25 is 2.78 times as big as 9. So if you try to use this relationship between these shapes for area, it won't work. You have to use this relationship instead. Then there's the volume. The k for the volumes of the two shapes is the cube of the original k-value. And the cube of 5/3 is 125/27. And 125 is actually 4.63 times as big as 27. The reason we have these decimals is because of the numbers we started with. In any math problem that is on this topic, you are not necessarily always going to be given 5/3 or 10/6. You can be given any two numbers and you have to be able to do this. This will change how many times bigger the volumes are or the areas, but it won't change the fact that the ratio for the distance is not the same as the ratio for the area or the volume. We have to go through this process of squaring or cubing, or possibly square rooting or cube rooting, in order to find the appropriate ratio and get to the end of our problem. Here we have an example. It's a simple example, but it forces us to use this knowledge. These two cylinders are similar. We have a large can and a small can. Picture tin cans that food comes in. The label on the large can required 980 centimeters squared of paper. The small can's label used 80 centimeters squared of paper. Those are areas. We're talking about centimeters squared. So what we want to do is we want to find our ratio, the k-value, and we do that by putting the two numbers together. But I want to simplify this. I can cancel, and I get 98/8, and that can be reduced by dividing top and bottom by 2, and we can get 49/4. The ratio between the areas of these two cylinders is 49/4. But the question's asking us about a volume. When they ask how many milliliters of soup fit in a can, that's not an area. So here's a situation where we have to do this stuff to get the appropriate ratio. And we can't directly go from an area ratio to a volume ratio. We have to go through the distance ratio as a step. So what I have to do is I have to square root 49/4 to get the distance ratio, and that's going to give me 7/2. And then if I want the volume ratio, I have to cube the 7/2, and that gives me 343 over 8. That's the ratio of the volumes. Now we can go ahead and answer our question. There's more than one way of doing this, actually. What we can do, and I won't show the calculations, what we can do is we can find the height of the small can by using this ratio, and then we can just plug that height and the radius into the volume formula of a cylinder, and we'll have our final answer. But another way we can do it is we can find the volume of the large can, and then we can use a proportion using this ratio to find the volume of the small can, which is the final answer. Either way, it's 2 steps, so it's up to the student which step they want to do first. But the bottom line of this lesson is no student can get to the end of this question unless they figure out which ratio they need. Either you're using the original area ratio to find the distance ratio if you want to do that method to solve it, or you're using the original area ratio to find the volume ratio if you want to use the second method to solve it. If this is a task on the final exam for Math 3053, this is a crucial concept because a question can be placed into the exam, which is a task, where doing this step with the ratios is actually a very early step in the process. And if the student doesn't know how to do it or just doesn't do it, then the student's marks on that question will crash. For instance, if it's worth 27 marks, a student who never applies the ratios at all and tries to answer the question might get 5 out of 27. A student who tries to use the area ratio to find the volume is doing it wrong, and also their mark is going to crash. They get a little bit more because they did actually try to use a ratio, but since they used the wrong one, maybe they'll get 8 or 9 out of 27. So it's very important to have this concept, and I would strongly recommend that when preparing a memory aid, this entire lesson with the example followed by the problem can be reproduced on the memory aid so that the student can have a model to follow, and then they can feel a little more oriented when they're in the exam if they get a question where they have to do this. Also, if you are doing this, I would suggest that you actually finish this. Do the calculations to find the volume of the small can, because you have all the information here to do it. And even do it both ways. Use the distance ratio to answer the question, or use the volume ratio to answer the question. I think the best thing is to use both ratios and answer the question twice. You are proving to yourself the power that you have when you understand this concept and can apply it in a situation.